Hey, listeners, before we get into this episode, I have some fantastic news. My new book, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms, is coming out, and we are having a book launch webinar to celebrate. This book spans from kindergarten to 12th grade, explaining in detail how algorithms trap students and what we should be teaching instead.
Join us at this free book launch webinar and you'll learn what the traps of algorithms are, how to avoid them, and so much more. You don't want to miss it.
We'll go live on March 18th, 7 p.m. Central. Grab your spot at mathisfigureoutable.com/book-launch.
That's www.mathisfigureoutable.com/book-launch. We hope to see you there.
Hey, fellow mathers! Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
Because we know that algorithms are amazing human achievements. And we also know they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop. And trap students into taking a digit focus, piecing everything into its pieces and parts and never reasoning about the problem as a whole. And it can trap them into an identity of not being a math person.
Yeah. In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Hey, Kim, I got to raise my desk just a second.
Okay.
I know. I just stood up, and it's when I'm, and you don't care, but I needed to be higher. It's higher now. Okay, there we go.
You got it.
Hey,
hi.
Hey, how's it going?
It's good.
Hey.
We're wrapping up a great series today. We've been talking about the traps of algorithms. You've shared about the 2 traps so far that kids have to deal with algorithms. And today we're going to tackle the 3rd. So if you have not heard the previous episodes, I invite you to go back and take a listen even now before you hit the 3rd, or you can go back afterwards and hear about the 3 major traps of algorithms.
Yeah. So, Kim, this has been work for a very long time that I've been pouring into my brand new book, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms. In these episodes, we're scratching the surface, giving everybody a feel for the 3 major traps that I think afflict all algorithms. In the book, I go into all the traps of a lot of the algorithms that we use and what to do instead. Really, here we're just kind of skimming the surface a little bit, but let's skim the surface on a super important trap, which has everything to do with our identities as mathers and how we think and reason mathematically. Yeah. All right. So let's dive in. Let's do a quick problem string. We're going to get some reasoning flowing, and then we're going to talk about how if we were to have solved some of these problems using an algorithm, how we could actually have been trapped in a new way. All right, So here we go. Kim, if you were to go to the bulk food aisle at the grocery store, could you imagine something that would cost $8 for 5 pounds?
Okay.
Maybe 5 ounces, 5 liters. I don't know. Pick your $8.
Okay.
It's got to be $8 for 5 something. Is there something that you can think about?
I was thinking 5 pounds, but that's, I don't know. It's like special flour. I don't know.
$8. Oh, how about salt for a water softener? Isn't that about $8?
Oh, I have that is not my job in this house. I have absolutely
you know
no idea.
No, I think I'm crazy because I think it's $8 for like 25 pounds.
Yeah.
Those bags are heavier than 5 pounds.
Okay.
I was just thinking of something that I knew it was $8.
I honestly am just picturing like a random bag. I don't know what's in it, but I'm picturing a bag. And I've got like an $8 tag on it. Yeah, I don't know. I'm going to have to go check it out when I go to the bulk food aisle next.
So if you went to the bulk food aisle and you put the thing in the bag and you walked over and you stuck it on the scale and then it came with little stickers and then you could see that it cost you $8 for 5 pounds. And you don't even know what's in the bag, but you can kind of picture.
Yeah.
And so 5 pounds, like that's, you're strong. You're strong.
Yes.
I remember when you did all that weightlifting, you got really upper body, your body.
Uh,
Yeah.
yeah.
Yeah. Are you still
I'm
weightlifting
lazy.
at all?
I'm
No,
lazy
you're
as
just running now.
heck.
Yeah. I'm
I work
starting
a
to,
lot.
I'm starting to do some
We're
more,
busy.
I'm starting to do a little bit more weightlifting.
That's great.
Yeah. Give me a few months before you check on that.
I'll follow up.
Anyway. All right. So if whatever it is that we just bought was 8 pounds, $8 for
Yep.
5 pounds.
Okay.
What if I had $16? How many pounds could I get?
Oh, okay. So it's twice as much money. So twice as many pounds. So 10.
Okay, so $16 for 10 pounds.
Uh-huh.
What if I only wanted to buy 1 pound? So it's
Mm.
$8 for 5 pounds, but I only want
Mm-hmm.
to buy 1 pound.
Mm-hmm.
Okay.
You just asked me for uh $16 and I found that it was 10 pounds. So I'm
You're
going to use
welcome.
that 10 pounds. Yeah, I was just thinking. I'm glad you asked me that one. So I'm going to use the 10 pounds and I'm going to divide by 10.
Okay.
So 16 divided by 10 is $1.60
Cool. So $1.60 would get you
for
1 pound of whatever that stuff is that we're buying.
Yep.
Okay, cool.
Mhm.
Nice. What if I wanted 32? No, I had $32. What if I had $32?
Mhm.
How many pounds could I get?
Okay, you just asked me about $16
Mm-hmm.
and that was 10 pounds, so I'm going to double it.
Okay.
$32 would be 20 pounds.
Okay, cool. And what if I really walked into the store and I had $33.60?
Mhm.
How many pounds? Maybe I had a coupon. Maybe that's all that's left on my credit card. I don't
Maybe
know.
that's your receipt and you wondered how much you bought.
Oh, very nice. That's
Mhm.
excellent. Thank you for helping my context there.
Mhm.
So if the receipt said that I spent $33.60 because I just was scooping stuff
Have
in
you
the
ever
bag.
sent your kids to the bulk food aisle and they roll up with, "Hey, you're going to get this bag"? That's happened to me.
There you
Happened
go.
to me.
That is good context. I like
Mhm.
it. All right, so they roll up and you look at it and it's $33.60. That's how much you're about to pay
Yeah.
that they stuck in the bag. So
Yeah.
how many pounds are you hefting right now?
That's a lot. I'm gonna say that the $32 I spent was 20 pounds,
Uh-huh.
and the previous $1.60 was 1 pound. So
Hmm.
add those together is 33.60 and 21 pounds.
All right, so
That's a
33.60
lot. I wonder what
would,
I'd
yeah, you'd be
buy.
that's 21 pounds. Can you picture that bag?
It's like a big bag of, yeah, I don't
That
know.
heavy. Yeah, I'm not sure anybody would get 21 pounds in the bulk
Maybe like masa or rice or something.
masa. What is that?
Like, oh, that's like for like tamales. It's like the
What-
cornmeal, I think, is what.
Oh,
I
that
mean,
makes
I don't
sense.
make
Okay.
them, so I don't, but
You just eat them.
I actually don't. But
Along with your chips and salsa?
oh
You're
yeah,
When people are eating tamales, you're eating the chips and salsa next to
uh-huh,
them.
for sure.
Okay. Yeah, that makes sense. Cool. Do you
Okay.
like spicy salsa or
Oh,
just
the hotter the better. Give me all the jalapenos. Give me all.
wow.
Yes, I
Really?
want my mouth to burn.
That's
I
you can
love
you
it. I'm
take the
gonna
heat,
sweat.
you take the heat and I'll take the
I
non.
do, and I have one
Yeah.
sweet little friend in my house who cannot handle any hot.
Oh,
None,
he's my friend.
none
He's
makes me so
yeah.
sad.
Yeah, we're not big heat people over
Oh,
here.
I love it.
Though I will tell you, we've been eating at our neighborhood Tex-Mex place, and I can now take some heat. Which
It's good.
doesn't that mean that I've killed some taste buds or
I don't
something?
know.
That
No,
yeah, whatever.
no, it's
Anyway,
good. It's good.
all right, cool. So Kim, would you consider that when you found the how when your kids rolled up with that bag, and on the tag it said $33.60 got
Yeah.
you 21 pounds?
Hmm.
Would you consider that we just solved the proportion 8 to 3360? So I've just written 8 fraction bar 33.6
Hmm.
equals 5 to x.
Hmm.
So we just solved that proportion. Now,
Awful.
I helped you, right? Like I gave you some
Yeah.
helper problems. I kind of walked you there, but we were developing mathematical reasoning so that we're developing proportional reasoning so that you could like reason about these about this ratio and keep the ratios equivalent and get to an equivalent ratio to where you found that x was equal to 21. Yeah.
Hmm. Hmm.
All right. So listeners, I would just invite you to consider that proportion. 8 fraction bar 33.6
Hmm.
equals 5 fraction bar x. If I'm in a traditional classroom.
You're crying. You're crying in a traditional classroom.
Well, you've just been handed a problem where if I'm going to cross multiply and divide, I now have a fraction, excuse me, a decimal multiplication problem.
Mhm.
And so now I get to ask myself, is this where I butt cheek the decimal, or is this where I line them up?
Yeah.
And maybe I'll do both. Like if we've heard some teachers just say, always line them up and then butt cheek if you're multiplying. So you've got that decimal multiplication problem. Then you're going to have to do long division. If you do that decimal multiplication problem, in that multiplication problem, you could use a bunch of additive reasoning. You could take that digit focus, and you could just, in that multiplication algorithm, do a bunch of digit focused single digit multiplication where you are either using additive reasoning or at best single digit multiplicative reasoning, trapped in less sophisticated reasoning. So notice, if I'm cross multiplying and dividing, the best reasoning that I'm using is multiplicative. I'm not reasoning proportionally at all, even though this is a proportion and I'm solving a proportion. I should be developing proportional reasoning. Let's just review. It's counting strategies to additive reasoning to multiplicative reasoning to proportional reasoning. So if I'm solving a proportion, I should be developing and using proportional reasoning. But if I'm cross multiplying and dividing, I'm using less sophisticated reasoning in the multiplication algorithm. I just made my hands go shorter, smaller. So I'm now in multiplicative reasoning. And if when I do that multiplication algorithm and then division algorithm, I'm using additive skip counting, then I'm using additive thinking, that less sophisticated. And in the addition and subtraction I do in those algorithms, I could be using counting strategies.
Right.
So I could be getting a correct answer to solving this proportion and using less sophisticated reasoning than the problem's calling for. So that's our
Yeah.
first trap that we talked about a couple episodes ago. Secondly, every one of those algorithms turns the problem into digits. So that's the trap we talked about last week. Notice that I'm not thinking about the ratio of 8 to 5 or the ratio of 8 to 3360. I'm not thinking about that as a ratio. I'm literally thinking about cross multiply and divide. I'm drawing a bat and a ball or whatever other
Mhm.
dumb thing that we've heard that people like. Y'all remember, if you're creating a story, chances are super high you've turned math into fake math. So I've definitely had that digit trap where I'm turning everything into just pieces and parts and I'm not really reasoning about the whole thing. Here's the last trap that I'd like you to consider. I invite you to consider that if we turn mathematics into rote memorizing and mimicking steps of algorithms, then we've changed the definition of mathing, into memorizing and mimicking. And
Right.
if we make that the definition of mathematics, so trap number 3 is the identity definition of math trap. If we have this distorted view of what math is, which it isn't, but we've turned it into rote memorizing and mimicking, then how does our identity deal with that? Well, one way it could deal with that is that we could say, okay, that's what math is. It's rote memorizing and mimicking, and bam, I'm good at that. Give me some more. Bring some more steps on. Well, frankly, that was me. In fourth grade, I was the first in my class to do long division. I didn't know what I was doing, but man, I can do those steps and smile and circle my answer at the end. And I had classmates next to me going, what's the next? Bring down? That's a mathematical operation. Like they were trying to memorize the steps. I have a younger sister. Now I have 4 sisters, so you'll never know which one this is. But I have a younger sister who cried every day
Mhm.
before she went to 4th grade, and my mom would, I was about to say, force her in the car, kind of like take her to school crying because
Mhm.
she could not get long division. Like it
Yeah.
was super, super traumatic. And we sat and worked with her, and it was not a happy time. And her identity took the hit of saying, if that's math, then I don't do that. Like I'm not a math person. We don't do math in our family. The third trap is all about the definition of math. And if we create the definition of math to be what it isn't, which is rote memorizing and mimicking algorithms, then we get these distorted views where I had the distortion of, sweet, I'm good at this stuff. What was I
Right.
good at? Fake math. Imagine the hit it took when I realized I was actually good at fake math and not good at real mathing at
Mhm.
all.
Mhm.
Or we get this identity of, well, if that's what math is, then who wants to be good at that? I'm not a math person. We don't do math in our family. We have a sort of national identity that there's a very few people that have the math gene and everybody else doesn't. No, no,
Right.
no. Everybody can math. Yeah, so this is the third kind of major trap, and I call it the definition of math identity trap, where we've got the definition wrong, and so now we assume these crazy identities. Well, let me mention one other identity that we could assume: those who actually see the shark, that low doses of the patterns out there, they're able to just naturally kind of they have the natural inclination or natural talent for math. All of a sudden, they become this weird elite in
Right.
our society. People would hear that I was a high school math teacher, and they would almost like take a step back,
Mhm.
like, oh, you're one of those. Like, we have this sort of strange, yeah, just weird elite. That's how we get this idea that there is a math gene and only some people, some special called people, could do math. No, 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 everybody can math. We just have to actually know it's a thing, like, and have the actual definition of mathing, the real mental actions that mathematicians do. Or we get these kind of really weird identity traps, and we get
Yeah.
trapped into identities that aren't, I don't know, aren't that we can stay out of.
Yeah, and some people, for some young learners, it happens early, like really early,
Super
first
early.
grade,
Yeah.
second grade. Some it's not until later, fifth grade, seventh grade. And for you, it was as an adult, right?
Sure enough,
So it's like,
yes.
it's not like you are making it out of school and then like you're off scot free. Like at some point, you were like, wait a second. And then you had to
Yeah.
take a look at your learning and really work hard and like set kind of a little bit of what you thought you knew aside to like take on the learning. And I think what you're suggesting is that we can acknowledge that that's a thing and help people earlier.
Absolutely. It reminds me of my neighbor Russ, who's no longer my neighbor. Russ,
Oh, we love Russ.
Russ, come back. Come back. Super, super guy. When he came over and he says, "Hey, I'm about to do this." I think he said more cool occupations than anybody ever. And at this point, he was doing some studying to take a test to be a bank something. I don't even know.
Mhm.
It was finance. I don't think it was like bank, but some finance something. And he goes, "I just don't understand eighths." And I was like, "What do you mean?" And he goes, 0.375 and point, like, there's got to be some rhyme or reason. And
Oh, yeah.
he said something like, I just was never really good at math, or not a math person, something, something. And I said, "Russ, like, you're a carpenter. Like,
Uh-huh.
he's super handy." And I said, like if you're measuring 1/8," and he goes, "Wait, wait, 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 wait. Like 1/8 and eighths, they're the same?" Because
Oh,
he was
yeah.
totally, someone had said eighths and then connected only to the decimal representations
Mhm.
because he was dealing with points and percentage points and stuff.
Yeah.
And he's like, wait, those are the same. And I was like, yeah. And he goes, oh my gosh. And he just like left, like,
Yeah, yeah.
he totally, oh, okay. Then, because he had so much experience measuring with eighths and fourths and all the things with our customary system, because he'd had that experience, I knew
Sure.
how good he was. I just had to connect it a little bit. But how tragic it is that this guy who's actually super good at all that stuff would have this identity of like, oh, well, like, not that real math stuff. I mean,
Mhm.
I can do
And it's
carpenter, I can measure, but not that other stuff.
it's so pervasive that people say that and other people go, "Oh," and like, yeah, okay. I
Well, that we
mean,
just take it.
it's
Yeah.
yeah, it's so sad. Yeah.
So, everybody, there are numerous traps of the algorithms. And in my new book, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms, I'm going to dive deeper into the three traps that I've just talked about, into the major algorithms that we teach and what to do instead. Y'all, we can actually help people math the way mathy people math. We can all be mathers, doing the mental actions of mathematicians, because we're not trapped by rote memorizing and mimicking algorithms.
Yeah. So get a copy of this fantastic book. Grab it for a book study with your friends, your teams, your leaders. Yeah.
Suggest it to your leaders. I think we've got a book study companion guide that's gonna be super helpful. In the book are QR codes where you can watch videos of kids who are trapped in less sophisticated reasoning, kids who are using the appropriate level of reasoning. We've got videos of problem strings where people are developing the reasoning before your eyes, using the sophisticated level of reasoning that we're actually intending to develop. It is a phenomenal resource. I'm super, super grateful to everybody who's helped write. My son, Cameron, who you've heard about on the podcast, was a huge help in writing the book. Kim, you did a great job helping review stuff and helping me come up with all the things. So grateful to Corwin. They've been fantastic. Looking forward to the 4-book series that will come after this book
Yeah.
that will focus on the grade levels. There'll be a K2, 3, 5, 6, 8, 9, 12 that will really focus on the major models and strategies in those grade bands and how to high dose kids with the major patterns to develop the kind of reasoning in those grade bands. Super excited about it. Thanks to everybody who's been major influence. And yeah, go check it out, everybody.
Yeah.
All right. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Hey, listeners, don't forget, go to mathisfigureoutable.com/book-launch to register for the free Developing Mathematical Reasoning, Avoiding the Trap of Algorithms book launch webinar taking place on March 18th. Y'all, I'm going to be there. It's going to be cool. You do not want to miss this. Totally free. Come join us. mathisfigureoutable.com/book-launch. We'll see you there.